We're here in Monte Vista, Colorado, South Central Colorado, the San Luis Valley. I've been in the Riverwatch program, both at the middle school and high school level since 2009 is when I got started. And I kind of inherited some legacy sites from the teacher that was here before, Doug Stewart. He was in the program, I think, pretty close to the beginning. And when he retired, I inherited one of his sites and added the one I was doing over at the middle school. So a lot of what we do here with Riverwatch, other than, of course, teach it as a class and get kids involved, is we use it as an outlet for doing research with the equipment and the access to all of these different field sites and the ability to create new ones when kids are interested in new projects. It's just fertile ground for any kind of project you can think of. So we had 3 students this year who utilized some of the Riverwatch support and river science as well. I'm going to segue Luke in here. So a conversation that Luke and I had way back in the fall about, hey, it'd be super cool to develop a robot that could take water quality measurements autonomously. And I'm like, I think we could get a student turned on to that. And so one of the students presenting here today, Chloe, will talk about her first attempt at engineering a solution to that problem. So Luke, thanks for that support. And I'd be remiss if I didn't mention Chris Vance. I know he's tuning in and he's playing this for some of his students. But Chris is our robotics teacher, and he was really the guy who mentored Chloe. I just poked my head in and say, how's it going? And Chris did all the heavy lifting. So Chris was the one who supported Chloe big time. But with that, I'll go ahead and turn it over to Camille Rawinski. She's our first speaker. And she was the one who used the support from Riverwatch to be able to sample sites down in Southern Colorado. I'll let her tell you guys all about that. So Camille, the stage is yours.
All right, can I share my screen? Does that work?
Yes.
Yeah. All right.
And again, your speakers are intense. I don't know if there's a way to take a notch or 2 down off of those. Or turn your speakers down, that'll help too. Feedback.
All right. Well, before I get started, I'm Camille, and I'm a junior at Monte Vista High School. So I became interested in this project, and I thought it would be really fun. And I really appreciate all the support that was given to me and all the help that I had during this project. It meant a lot, so thank you. Right. So I can go ahead and start whenever it loads. All right, well, I'll go ahead and begin then. So in North America, the spruce beetle has killed more spruce trees than any other natural cause. And since beetle kill is seen in nearly every forest from Arizona to Alaska, I wanted to look further into the effects of beetle kill. So I looked at the effects of spruce beetles on aquatic ecosystems using macroinvertebrates and water quality sampling in Conejos County. So for this project, to start, mostly when people think of beetle kill, they think of terrestrial impacts. So that's kind of why I wanted to look into something people have not put a lot of research into. So I looked at the aquatic ecosystems and that portion of the land. So for this project, I used an integrated monitoring technique, which takes into account the chemical, physical, and biological components of a stream to monitor health. So for my biological component, I looked at macroinvertebrates, more specifically bioindicator macroinvertebrates, which are very sensitive to any sort of pollution, and they require very specific environments to live in. My chemical component was based off of water quality, which lets you know how well a stream is functioning and how healthy it is as well. And then my physical component was measured by certain visual characteristics such as flow rate, bank stability, size of the stream, a bunch of that stuff that can deeply affect the ecosystem as well. To start off, I identified 4 watersheds with different forest stands in those watersheds. The first one is my mature healthy forest. The second is my standing dead forest with severe beetle kill impacts, as you can see. The third is the newly growing or sapling forest with those new small trees, and the last one is a logged forest. So for this project, I predicted that my mature healthy forest would be the most beneficial to supporting aquatic life and result in a healthier aquatic system, because the increase in shade will decrease the chance for thermal pollution to occur, which is a harmful increase in temperature that can affect the organisms in a stream and the water quality negatively. All right, so after I picked out my 4 sites, I collected macroinvertebrates. I did 16 kicks using a kick net in each stream to fill 8 sample bottles per stream. So a total of 32 bottles, in which I eventually sorted, identified, and counted all of those. And after many, many, many months of work on macros, I counted over 61,000 individual macroinvertebrates, which was incredible, and it was really cool to see the different types there as well. At each of my streams, I also collected those water quality samples, and then I ended up running my titrations on hardness, my alkalinity, pH, and dissolved oxygen. And I also looked at metals too, with the help of all of you guys. All right, so this shows the chemical factors of my stream health, I guess. And note that the standard health value over here refers to the maximum contaminant level for drinking water. So anything in green means that the level of contaminants in my stream is less than the drinking water, or equal to. And anything in yellow exceeds that maximum contaminant level, which is not the best, but it depends on how much we're over by. So as you can see here, if you look at my log stream exceeded those maximum health values in aluminum, iron, and in potassium. Whereas my forested and dead streams, they only exceeded in one, which was iron. So conclusions based off this is that all my streams are pretty well set with water quality. There's nothing that was too concerning about each of the streams, so they were all fairly good. As for my physical factors, I have all 4 of my streams here, as you can see. And if you take a look for the sapling and the logged streams, they had the most channel alterations due to cow damage, fallen trees, and then my sapling stream also had not the best bank stability, it wasn't the best, but overall, again, my forested and dead stream had minimal impacts, and they were composed physically very well. As for my biological factors, these colors that you see here were tested through statistics. So any color differences equals a significant difference. As you can see, my forested stream had significantly more individual macroinvertebrates, families per sample, bioindicator individual macroinvertebrates, number of bioindicator families, and then the biomass of my bioindicator families. So those are all really good signs, because it shows that my stream, my forested stream, was able to support those sensitive species, and that was a really good thing. As for my dead and logged, they were pretty identical. They were very similar in their components, and they were, I guess, in the middle. And as you can see, sapling fell far behind, not having the best biological features. And as for the fish presence, I did see fish in the forested and log streams, but I didn't see them in the dead or sapling streams. But that doesn't mean they're not there, it just means I didn't see them. So table 4 shows an example of my statistics that I ran on all those biological factors that you just saw. I started with analysis of variance tests to compare all my streams to find if there was significance. And once I found significance, I further ran t-tests to compare 2 variables at a time to find the source of significance. As well as over here, you can see my table of my total number of individual macroinvertebrates in each stream. As you can see, my forested stream had significantly more macroinvertebrates than all my other streams. Now, these are the average number of individual macroinvertebrates per family in each stream. So this one is color-coded based on family sensitivity. So anything in green means they're very sensitive. Once again, they cannot handle pollution, require those very specific environments to live in. And the yellow is somewhat tolerant of pollution, and the red is tolerant of pollution. So as you can see in the table, there are many sensitive macroinvertebrates, once again, in the green. And in 6 out of 11 of those species, they're more prevalent in my forested stream, which once again is a good sign because it shows that that forested stream is able to account for those sensitive species. Now, these figures 2 and 3 are just examples of my dissolved metals in each stream. I collected dissolved and particulate metals in those streams. And once again, they reflect the same thing I showed in the first table. There was nothing too concerning, and overall, it was pretty good water quality. So I'll say this once again. Nothing was extremely concerning. They were all pretty good, but the log stream contained the most negative characteristics out of those chemical factors. And my physical factors, the logged-in sapling stream had the most negative qualities because of that those channel alterations and bank instability, whereas my mature and the standing dead forests were were composed physically well. And as for my biological conclusions, the mature forest was a little bit dominated, but other than that, most of the other traits biologically were significantly healthier than the other streams. So, all in all, beetle kill has had significant effects on those aquatic ecosystems. And this project is very important because it can inform not only viewers like ourselves, but other land managers of harmful effects of not only spruce beetle, but on climate change, which is likely to have indirectly influenced this process, as well as thermal pollution, which shows that it can really affect our aquatic waterways. Now, this could, well, I guess the recovery of the dead and logged forests may take many years. Like it's very unknown and it changes based on the forest type. But since it would take a while for these places to recover, it will affect multiple things down the road, such as possibly the food chain based off the decreased amount of macroinvertebrates in those other streams, as well as the sensitive and threatened species like the Rio Grande cutthroat trout that are trying to survive in these conditions. So overall, my project holds significant potential for the future because since I've established each of my 4 streams as Riverwatch sites, they are able to be reviewed and assessed in the future, which allows for a lot of potential research to be done to further explore these effects. So that's all I have, and I'd like to open it up to any questions you may have.
Nice job, kiddo.
I have a question. Do you guys have any questions? I know you might have to get to the field.
Yeah, I have a question. What was you might have mentioned it, what was the period of time that you sampled for?
So basically, I did all within 1 week, or technically. This was in July, and I did them. It was too much to collect macroinvertebrates from each stream in 1 day, like to combine all those streams into 1 day. So I did 1 stream a day based on macros, and then I collected all my water quality samples in 1 day just to minimize that variability, because I know certain things like the weather and rainstorms and all that different stuff can affect the water quality, so I wanted it to be consistent.
I have another question.
Yes.
So you said you've established these as Riverwatch sites, correct?
Yes.
How do you think it would change seasonally, if at all, if you were to keep sampling at these sites? do you think you'd see any variability between the different landscapes?
I think it would change a little bit based on the season, but I don't think it would change anything too significantly. I mean, as for macroinvertebrates, that could change a lot because, as you can see in this table, I had a very significant amount of midge flies hatch during my testing period, which resulted in this unevenness and this dominance right here. So my macroinvertebrates might be able to change quite a bit because they just hatch during different seasons, but I don't think the water quality would change too drastically. I know it would change, but not very significantly.
Anyone else have questions?
Camille, if you could, go back in time and add additional parameters, like if you had more resources to help with some of the conclusions that you drew from your work, what might you add?
Well, one thing I was kind of bummed about that I didn't get to do was sample for those nutrients in the water because I was in the wrong season and I wanted to keep all my testing once again during the same time period to limit variability. So if I was to go back in time, I might have scheduled my testing date so it would align with that season so I can collect the nutrients there.
One of the things that intrigued me was, like canopy cover and your link to thermal pollution and kind of the influence of shade and cover. I thought that was an interesting piece that could be explored even more. Like, what does canopy cover look like, and how does it affect these aquatic communities? So that was
Absolutely.
Yeah.
How did you count all those bugs, and how did you not go crazy?
No one said I didn't go crazy. I think I did. But I counted them all by hand. It took a very long time. I started by picking them out of the debris, identifying them, sorting them into their own little tubes and vials. Then I had to go back once I did all 32 bottles, went back, resorted them to make sure they're correct. And then I just counted one by one, over 61,000 of them. So it took a very long time.
She loves bugs now.
Probably start looking appetizing after a while, like getting a little crazy. No, that's very cool. This is
I
an
started seeing them in my
project.
sleep. Thank you.
And Camille, you had a lot of people who said, could I see your report, or after the fact, will it be published on our website? You let us know how we might be able to, highlight your really cool work and share that with other folks.
Absolutely.
I certainly know I would love to stare at your tables for a little bit longer.
Yeah, of course.
Yeah, I'm sure we can upload PDFs. We can shoot those to you guys, and I think it would be great if you made it available for other folks to look at and to inspire other high school students too about the type of work that's possible.
Any questions?
This is Jerry from the City Stormwater Group. I just want to say great job on the research, and you did a great job presenting it. Thank you.
Thanks. I was a little rusty, but I appreciate that. Thank you.
This is a good warm-up. We have another competition this Friday, so she's going to present for a Junior Sciences and Humanities Symposium, which is in Albuquerque. It's a virtual affair, but that comes up in a few days, so this is good practice.
Yes. All right.
It's impressive.
Good job.
Thank you.
Yes. Thanks a lot,
Thanks.
Camille.